it's and go to the screen. Okay, look at this website here. Right. So we continue the first paper, right?
Yes.
When did you decide to take the exam?
Sorry.
When did you decide to take this exam? Recently?
Like a few months ago.
Oh wow, big decision.
Yeah.
Okay.
Do you think it's really hard?
Well, I think you should be right. Because I think you absorb new things very quickly. It's good, and also I think I have several months, right? It should be all right. And so we got his number.
Mm-hmm.
Do you have a second thought about this? Yeah.
I haven't had a look at it yet.
Yeah. Okay. So just I thought can just probably give some remark on this issue. Yeah, we can always revisit some question, right? Because when they get familiar with, so these things 32 remind me the base exponential base should be 2, right? It's likely the base should be 2.
Yes, but doesn't for the second one.
Yeah, well, it's not simple as a number. It's not as simple as that. No, they probably have a fraction. Okay, it could be have 1 plus n plus n. They probably have some fraction. You see, they probably have 2 divided by 2, or you see. We just make some few remarks. So basically, if you start with this exponential start from 1, right? So if you have the base a base 2. And this is 0. So when this is 1, when base 1, so this will be 2. Okay, I just focus on this 2 for time being. Not much. I just have second thought apart from the graphical method. So this is our variable n. Can you see? Or you can call it n. You can call x. Doesn't matter. So this is 1. All right. Maybe we call it x because in this way we can figure out the exponential form, right? Now, to this number, so you will learn how to get familiar with these numbers. What is power? 5? Is this 5 or because 2 to power is 5, right? So what can we do? What can we do to rewrite this 5? This 32. Can you see? So it would appear that if we bother this number is 1, and we have several options. One is y equal to 2. So that should give 5, right? Should be we multiply. It must be fracking here. Can you see? It should be fracking. As that will ensure when x equal to 1, this is 1. Can you see? Because this start from 1, right? So we have figured out this fraction. Can we? So can we? How can we simplify this? If this is x is 1. They should the fraction. Can you see the fraction a and b must be equal to 5, right?
Yes.
And when a that is 1 multiply that 1. How about x equal to 2? Say
2a over b.
Yeah, 2 multiply this fraction, this a and b divided by b. How about equal to 2? When equal to 2, so that's our third term, right? This is 0, 1, 2. Can you see the third term? Oh, hang on. Wait, this one. So this 0, this 1, this 2. Okay. So how can we generate this number 243 by? Oh, it's integer, right? Oh, it's very challenging. It's integer, right? There's no decimal. Oh, probably not. We're not continue here, right?
Okay.
I thought probably with this, if they have organized, they come up with a fraction, but it's not straightforward.
I think the graphical method will still be better.
Okay, yeah. Oh, that remind me. So when you take exam, why don't you bring that Greek this paper notebook with that what is a grid with a grid, right?
Oh, grid line, yeah.
Yeah, grid line. That will help you. You don't have to draw the straight line. You see, you can renounce that to draw perfect graph.
Okay.
Okay. Let's go to next question. We have done several questions. That's one we did.
Yeah. Starting from here.
Can we start from this one? The gravity?
Yes.
That is a gravity of the moon and the Earth. Obviously, it's different, right? It's actually this moon is actually 1/6 of that gravitational on the moon. Yeah, obviously. By the way, do you know the formula for the gravitational acceleration?
mg.
Yeah. So what is the formula? What is the formula for g? It must be something to do with gravitational constant,
m,
right? And capital N, what is that? Is a mass, okay? That is mass N, and divided by r squared. Yep, that's a formula we can apply, because if you're talking about a surface, and we just use a different. We can use so this can be applied for any distance. Okay. Okay, let's see. What is the question? Do you want to read the question? What is the question?
On Earth from a height h, take a time t to reach the ground. From which height should it be dropped on the moon so that it takes the same time t to reach the surface?
So this is different g. This is Earth, right? So yes. This g is e. Can you just use the Earth?
Yeah.
And another is as on the moon, right? So ERTH is the moon.
1/6g.
Yeah, so that is 1/6. This is the moon. So that's so what's the height is h? Can you see the height is same height? To talk about same height?
No, talking about different heights.
Different height. Okay. Yeah. A ball drop from Earth with high time taken is t. Okay. So do you know this formula? The t, the free fall. For free fall formula, the height. Do you know this formula? G t square. This is the formula for h. There's a relation between this h and the t.
It looks like a kinetic energy.
Kinetic energy, yes, but you are right. But this is quite a different object. So basically, if you drop from Earth, take the time t to reach the ground, from which height? From which height? So this question, right? So from which height? So can we call it h? Can you use a different h, right? So h is unknown. It dropped on the moon so that it takes the same time. Okay. Yes. Yeah. If you are, I just highlighted from this very basic formula when we're dealing with
mechanics,
kinematics, right?
Yeah, I think that one's the Suvat equation.
This is a special equation. The general equation from this Newton's law is equal to the displacement. Do you know this formula?
Oh yeah, that one. Yeah,
that's right. That's initial. If the initial velocity equal to 0, then that we have this form. Okay, it's nothing to do with the kinetic energy. Yeah. All right. Okay, are you able to write? Can you write the equation between these two? This is the moon. I think this is not very challenging question.
Yeah, I think it's easy too.
Yeah, can you build the equation? So this is one equation. Can you see? Can we call this equation 1? Yeah. That is for the moon. Can we use capital H? Okay. Oh yes, you can use the subscript. It's all right. Yeah, you use the subscript.
1, 2, G.
But I prefer use H because they already use this letter. Can you see? You just use a H, small, no case, just represent the height on the Earth.
Oh.
And the unknown H, can we use capital H?
Okay.
For the moon, yeah. And that is E. Can you see? That is E. You see?
Yeah.
Right. Yeah, this should be not that difficult. Ah, you mean the one, where should I put your G? Your G is not in the right position. So from this formula, we can subtract the moon by 1 is divided by 6, not divided by 6G. Can you see? Ah, if that is Earth, can you see? So you have to clarify what you're trying to do here. Can you see?
This one's on the top.
Yeah.
This one's on the top.
That's right. Oh, be careful. Yeah.
My handwriting.
This is called a silly mistake. Okay.
Yeah.
The so-called silly mistake is that you know the principle, but the method, but you make some mathematical error. Can you see? That's
I'm just writing on the iPad because it's like
very
vertical.
Right. Yeah, just remind you. Yeah, can you rewrite that? So this is our equation. Can you build the equation? Yeah, that's it. Can you only finish? Can you just rewrite this part so that you can compare?
It's the same time. Doesn't mean that they can cancel out each other.
Yeah, these T are identical. Can we put these two equations together? Can you see? One equation is Earth. Can you see? Okay, that is half GE. Okay. There's a notation is very important. If you use a proper notation, that can simplify. So H on the moon is half. And by this time, you have divided by 6, right?
Yeah.
Yes, that's right. That's why if you use their T, then we don't have to define a new variable. How to simplify this? So what is unknown? So they are looking for H, can you see? The H, the correct H is among the 5 numbers, 5 results.
Oh, I got it. You use simultaneous equation.
How do we solve this type of question quickly?
H over the half times GE equals H over a half times.
Yes, the T square is identical. Yes, okay.
Yeah.
Okay.
So H.
Did you use a pen? If you have pen, it'd be quicker. If you use a pen, good. Yeah. Some people use a mouse. It's not very.
Okay. The G divided by 2 equals. No.
It's a bit algebra. Got a result? You should get a result in 2 minutes. Less than 2 minutes.
My mind is messy right now.
Yeah. Yes. Okay, how can we simplify? Yes. Ah, we got H. Yes.
Oh.
Wow, got it. Yes. One of them, B, right?
Yes,
it's a B. I show you how to speed up this. Okay. A bit. If you got 2 equations. So in this type of equation, to solve this simultaneous equation is the easiest way to do division. Can you see? Yeah, can we divide that by 2? Can you see? If you divide that, what we have, we got H over H. Can you see?
Yes.
And at half and GE and T square and it's cancelled. Can you see? That would be 1 over 6. Can you see? Can you see that? We just divide. And this one can be 6 simply written as 6. Can you see? Can you see that that's much quicker? Can you see? H is solved. Yeah. Okay. Is that quicker?
Yes.
Yep. So that's so you apart from just cross product, you can just divide. All right. Okay, good. We have solved one question. Saved one. Clear. Next one. Yeah, some of them are. This question is quite simple, right?
Yeah, I think this should be on our exam. The external exam.
External exam? Or you are still preparing for external exam?
I'm preparing for mock, and after mock is external.
Okay.
Yeah.
stop that quick. So that is next question. This is probability, I think, right?
Yes.
Have you how's your statistics?
We just tested on that. Like,
oh, that's good. Good. Can you try?
Yeah.
That is presumably that how to count the outcomes, right?
Dice are rolled and the number obtained are added.
The sum, the base, yeah, that the probability represents the sum, two numbers. So they basically have 6 numbers, right? 6 different numbers.
Yes.
So you have to work out this number. This number here represents the sum. You have, that is how to, you try it. You try first. I probably will participate after a while.
Oh, so difficult.
Have you tried this type of question before? The die? Did you put, in statistics, we use the die all the time, right?
Yeah, we only use like single dice.
Single die, yeah.
Yeah, this double dice is like when there's some could be like lots of combinations.
Yeah, there's a lot of combination you have to count. Yeah. So you have to, so basically you have work out, do you want to try or want to give you some remark?
I can do it, but I think my method is kind of like very long.
No,
I'm just gonna count every possibility of the combination.
I think if you have see this, that would be helpful you. If you have see this table, that's particularly for 2 unbiased die, you see, and also for the sum. So if you have, I just moved this the table here. If you have seen this table before, so what you do, you put this side this possible outcome for each die is 1, 2, 3, 4. Sorry, not I mean 4, 5, 6, right? What I'm writing is always more than 1. If I'm thinking something else, this is 1, 2, 3, 4. Have you seen this diagram before?
Yeah, matrices.
It's like matrices, but that is have you studied the group? Probably not. In the previous, they studied not a group. Do you know the group mathematics in group theory?
No.
So this just built the group. They put it the sum. Can you see?
Oh.
So everything here is a sum. Because 1 plus 1 is 2. Can you see?
Yes.
2 plus 2 is 4. 3 plus 3 is 6. If you add them up, so the 1 plus 2 is 3. Can you see?
Oh.
Can you finish this table? Or you can call matrix is just a table actually.
Yeah.
Just make sure got all outcomes. That allows you to work out all outcomes for 2 die, a sum when you count the sum. So basically, it's impossible to get 1. Can you see? So there's no such thing as 1. Okay, it doesn't exist. So this doesn't exist. Group. This is called the binary operator. If you have study groups, they call the binary. Probably this new syllable they don't teach you anymore. It's called the binary operator. In other words, just put 2 elements together to find the sum. However, if you use multiply, and that will be the product, all these numbers will be product. It doesn't matter. I just remind you. Now you can count. Now can you see?
Yeah.
The probability, the repetition for 12 is just 1. Right? Can you see?
Yeah, it's straightforward. It's 1. 1 is true.
Yes.
Probability of 6.
How about the 6? Yeah, how many 6? We got, can you see the diagonal one? it's called a diagonal. It's got several probability, right? A pop chance. Yes, just have to make sure you count them all. You see if you count that direction. Actually, a 10-year student actually use this table trying to write his assignment. I was a little surprised. How did he use this? Year 10 student. He uses. He asked me for his assignment.
Yeah, I think we did an assignment.
You did before, yeah.
On a matrices thing, but not like this.
This is not matrices. Yeah. This is just this is a part of group theory. How to you do the binary operation.
Three is
2.
4, 3. 7 is like 6. Yeah.
Yeah, 7 is 6. Yeah, 7 is high. There's a is most.
The second. And this is 4 times 3 said 3/2. 6. Yes.
The 2. Okay. 1, 4. 11 and 3 are they equal to 2? Yeah. Okay. If you run out of time, you just use this table to count. Can you see?
Yeah.
If during examination you want to save time, you just count these 3. Can you see? And which is you just count this. You just count it.
It's already a save time method. Is there any more methods?
Well, we'll discuss how to save time. Okay, but first we have to understand the method. Okay. And okay, I've done it. That's good. Save that. Go to next one. Yeah. Oh, I have to stop that. It's very strange. Sometimes it didn't work. Okay, let's stop. Go back. Next one. It's like optics, right? Optics.
It's just one math, one physics, one math, one physics.
Yeah. Alternate. Okay, give it a try. Can you try? So that gives you the pathway of the of light ray. Can you see in the 3 different media? So what is the question? Can you read the question?
Light ray flows a path through 3 media separated by plane boundaries as shown in the diagram, with refractive indices 10 and 3. Which of the following sequences puts the refractive indexes in order of increasing value?
That's right. So which order? Which is order?
The equation is n1 sine theta 1.
Can you see the reflection occur at the second? This is can you see the reflection occur somewhere? Reflection is a mirror. Is a mirror underneath.
Yeah.
Can you see? There's a mirror here. There's a mirror. That's right. So basically, the larger. So you can just say to keep that a constant. The larger the n and smaller the theta. Not that theta. Be careful. The theta must be the angle between normal direction.
Isn't this normal direction?
No. Normal direction. This is normal here. There's normal direction. Can you see?
I messed it up. Yeah, I saw the vertical one is normal.
This is normal direction.
Yeah.
So you have to know how to rotate. You see, some question mathematical physics is rotated by 90 degrees. So when you apply the basic formula, you have to. Okay. So the angle decrease. Can you see?
Yes.
So angle decreases what would happen to the refractive index?
Increases.
Yeah.
Right.
Well, no, you can just consider the product. You see, if something is equal to the product, so this let's just write down here. So if you have the product, can you still have product? The product equal to A and B, right? Now, if that is a constant, so this is A and B must obey the reciprocal, what's called reciprocity relation. Can you see?
A increases, B decreases.
That's right. So in this case, if this angle decrease, can you see this theta 1 is larger than the theta 2? Can you see?
Yeah. So N1 must be smaller than
I just use this diagram here. One is sine theta. Sine theta is also increase with theta, right? So it's reciprocal like that. All right, N2 is larger. How about the N3?
I don't know about reflective.
Well, it's not transparent. Can you see? It's not transparent. Yeah. So in that case, N could be how to define that? If it could be total reflection, could be yes. Be careful. That's very smart design. This could be a total reflection. Do you remember total reflection? Can you see if total reflection occur, and in this case, the diffraction direction will go that way? Can you see? This will be challenging question, or not very. You have to react. Can you see? Can you see? So in this case, the angle here, the angle would be like this. Can you see? This angle 3. Can you see?
Yeah.
Equal to 90 degrees. Can you follow me?
So hitting on a critical angle, which some of them refracted at like perpendicular to the normal, and some of them reflect.
Well, basically, there's no transmission. So all these called you in terms of direction, you call it refractive, right?
Yeah.
But in terms of the way they travel, this is called transmission. In this case, I just draw your attention. In this case, it could be could be this case. Can we just highlight this color? If this is if this is color like this, can you see? You see that? So in other words, do you remember in the internal total reflection, what is the condition? Which does that occur in the less denser material or more
from a denser material to the
yes, that's right, the denser. So this is the denser one. So therefore, that N2 must be larger than N3.
Oh,
can you see that? Because when we studied this part, do you remember we just put this horizontal? Can you see? When we start the total, this is just review this idea. This total internal reflection. Total what that matter is total internal reflection. Internal total reflection. That matter just the proper name is this is internal inside the denser material. Internal total reflection. Okay. When we study this part, we assume the light comes this way. Can you see? The light come. I use arrow here, perhaps. There's an arrow here. So we assume light comes this way. All right. And under critical position condition, this light will be refracted here. You see. So that is how we introduce that formula.
Oh, right.
When we study that, so that's why you have to learn how to rotate by 90 degrees. Can you see? this can you see? So that is that is angle. That's called critical angle. Okay. And this angle is 90 degrees. Can you see?
But why would that reflect though? It's not
reflection still occur. You see, actually reflection is the maximum because I didn't draw the reflection. because they draw the reflection. We can draw the reflection. Reflection is well, I just want to, because there are two phenomena here. One is reflection, another is diffraction. Okay.
Okay.
The total reflection occur when the diffraction is along the surface. Can you see?
Yes.
So if I call this is do we call it N2, right? N3, you see? If you use this formula, then we can still use a Snell's law, and that is a critical angle multiply sine critical angle. Okay. Sorry, this should be N2. Yeah, N2 must equal to the critical angle outside. Okay, and equal to multiply 90. 90 degrees 1. You see?
Yeah.
Okay, sine 90 degree is 1 degree. So that is why the critical angle. So sine critical angle is equal to N3 and N1, N2. Now, because this angle is always larger than 1, so therefore this must be less than 1. Can you see? Because for sine theta, they cannot go beyond. Can you see? There's another argument. Is the sine theta is always less than 1, the value of sine theta. So that is we introduce this formula here. Can you see?
Yeah.
Yeah, that's very. Go on. Question.
When would reflection occur?
Reflection or refraction?
Reflection.
All the time. As long as it's transparent, that's semi-transparent, as it's transparent or semi-transparent. Another thing you wouldn't go through that they could be encountered error. So mirror, can you see? Another scenario you probably encountered mirror. That was my first response. I thought it's mirror, can you see? But actually, apart from this scenario, you have to consider refraction.
Yeah. Okay.
I think it's a very good question, right?
So how do you compare refractive index between N1 and N3?
Well, that is another issue. So can we just make the decision first? Can you see?
Yeah.
So then you have to consider that in that case, so which angle is smaller? Can you see? Can you see this angle, can you see? You have to follow their diagram to see. I have drawn too much. So basically, these two angles, this angle is smaller. Can you see? This angle is larger, and whereas this angle is smaller. Can you see?
Yeah.
This you can consider as a critical angle. If that is the case, good question. Yeah, we have to think further. Can you see? Can we write the two equation here? Can you see? Two equation here. So basically N1 multiply sine theta 1 must equal to, so this our theta 1, this theta 2, can you see?
Yes.
This theta 2. So this is the N2 multiply sine theta 2, right?
Yeah.
Sine theta 2. And sine theta 2 must also equal to N3, can you see?
Yeah.
And that's sine theta 3.
Isn't sine theta 3 90?
Yeah, that's in this case, in particular case. So that's equal to 1. 3, okay, that equal to 1. So can you build the relation? So that obviously basically this must be equal. Can you see? These two must be equal.
So N1 larger than 1.
Which is larger? You compare these two, because sine theta is smaller than 1. Can you see? So basically, if you multiply something smaller, so therefore, so N1 must be larger than N3. Because this factor is smaller, can you see? Sine theta, this sine theta is always smaller than 1.
Oh.
Does that make sense? For example, if you have A multiply 0.2, right? And equal to B.
Yeah.
Okay? So therefore, B is, which one is larger? A is always larger than B, right?
Yeah.
So can we put the order together? Which is increase in the increase?
1, 2, 3.
Right?
Yeah.
1, 2, 3. 1, 2, 3.
Mm-hmm.
Oh, you are quicker. Are you sure? 1, 2, 3. Yes, that's right. Yeah. Okay. That's this one, right?
Mm-hmm.
Oh, this is fun. Okay, this they implied total reflection. Can you see?
Yes.
Can you see if you say if this is opaque, if this third one is opaque, they wouldn't give you this index as you ask the right question, right?
Yeah, because
if it's a mirror, they wouldn't give you the index. How can you apply the mirror? How can you apply the index, refraction index for the mirror?
Yeah,
that's good.
Okay. All the questions are like so refreshing, like when we done them.
Well, we have just it's good because we have make sure and we don't go beyond the scope, right? And otherwise you don't have much time. You have to focus on. But that is this is the first time, okay? Yeah. We probably have do more past work. Let's just talk to this way. To the next question. This question. Mathematics. Oh, this is alternate, right?
Derivative.
First derivative. It looks like the. Can you try? Looks like the they are dealing with composite function, right? Oh my God, I've never seen that. No, you see that the composite function is which rule can we apply? Composite function. I don't know. Chain rule. Have you used chain rule? How do you like write that? Oh, sorry. You can write, yeah, it's called a chain rule. You can write anything, yeah. Yeah, I know chain rule, but I don't know how that. So if you have this function, can we say, or you can simply write this as fg. Can you see? It's like this. Well, not yet. I just remind you what's the chain rule, okay? Yeah. If this is the case, g is a function, and g is a function. Oh, we know g. And can you give the g? G is a function. Can you see? G is a function of the x plus 3. You are right. Can you see? Yeah. You jump. Yeah, you are quicker. Yeah, you are quicker than me. Yes, that's right. If 3, okay. And therefore, what we can do the first derivative, df dx, right? Oh, that's easy. Yeah, you just use, yeah, that's very easy. I don't know why. What did the UK students study? df dg, can you see? And dg and dg, and it's dg, so it may make feel dg dx. Oh. So the question is, I use their notation. I use their notation, okay? So what is fg? Can you write this question? What is fg? FG? I don't think so. No. Yes. Yeah, that's right. Yeah, that's right. You just because that is an independent variable. Can you see? You you just replace x by g. Okay. Okay. Oh, actually, as simple as that. No. They're asking for divide dx. No. Before this is not right. This is not right. And the correct answer is that fg. You have used their formula is simply equal to g squared. Because I use this according to this formula for f function. Can you see? Right. Can you see? If you have function of is a square of independent variable, then you can write a different form. So how about f theta? How about f theta? Theta squared. Yes, that is a basic algebra. Can you see? Yeah. You can use a different variable but the form must be the same. Okay, can you use the chain rule, or you can use other way? How do we work out this first derivative of the difference, right, between the two? Ooh, it's not they have fun. You see, the second one is a slightly different form. Is it not like x squared plus 3? You just replace the
with the function.
Well, I don't think I cannot follow you. Can we just write y as the sum of the two, right? Can we do it separately? Can we just, because y, can we just rewrite that y is equal to f and minus g, all right? Can you see that?
Yeah.
Minus fg and gf, do you agree?
Mm-hmm.
Of course, f and g is a function of x.
Yeah.
Okay, so both, so what is a g? And in this case, g is equal to, that's the relation between g and x. It's just x plus 3.
Yes.
However, in this case, f is what? What is f? F is x squared. X squared. Okay, good. So you still have to apply the chain rule. Can you see? Can we write the chain rule for you? dy dx or equal to, can we do the one by one? The df dg, can you see?
Yeah.
And the dg dx, all right?
Uh-huh.
Plus, minus the second one, dg df, can you see? And the df dx. All right, can you find these four derivatives necessary? What's the df dg? What is f in the function of g?
2g.
No, g squared. Oh, you got the result. Yeah. Oh, good. That's quick. It's quick. Okay, that's good. Okay, that's 2 step. Yeah, 2g. Yeah, 2g. Okay, okay, go on. You can try. You can write here.
2g times.
What's dg dx?
1.
Yeah, dg dx.
Minus dg df is
g in the form of f.
To f times
12, are you sure?
g in the form of x.
Yes, you have used this time. You have used this mathematical form. That's not necessarily the same. I'll show you. So based on this formula, you see x is independent variable, right? But when this variable became f, then gf, you have to write it correctly. Gf should be equal to f plus 3. So that is the formula for dealing with this variable. So df, dg, df is just equal to 1. Can you see that?
Yeah.
Now, how about df, dx?
2x.
2x, yes, that's correct. All right, nearly finished. Can you rewrite g in the form of x?
Yeah, x plus 3.
Yeah. You can continue, right? This. Oh, yeah, okay, finish that.
It's not in the answer.
Can you continue from here? What is a g? Is it 2? Yeah.
Stupid mistake.
Yeah. I just you can finish all this in this square.
Okay.
Two x cancel. Yes, we got one answer. Which one?
A.
Yep. Good. Yeah. So you don't underestimate this complexity, because they have to think that how to use this function form, right? The important thing is the form. You see, they say if you have the quadratic equation, right? Quadratic equation can be written as y equal to 1 x squared, say 10x squared, okay? And what happened to my side? X squared, can you see? And this is 5x, can you see? Plus 1, for example, or another is also h is also can write a function, can you see? You write 10 to the you can use different letter now, can you see? You can use a k squared, can you see? Minus 5k. But the formula for quadratic equation applied to both this function. So you have to get familiar how do we replace, use a different letter to represent that independent variable.
Okay.
Let's save that. Oh, good. We have made some progress now. Can you see?
Yeah.
Let's just I cannot find it. Oh, I just stop share. Go back. So DC circuit resistance. Okay.
What's the current at the point P?
P, yes.
Oh.
In the diagram. So you have used either Ohm's law and the formula for the configuration parallel or the
I want to try
series. Yes.
Is this parallel?
Some are parallel. The three 2R are in parallel, and the 2R are in parallel, but as a whole, they are three equivalent resistors in series.
Is this equation for parallel?
Yes, that's right, for parallel, yes.
Can I name them?
Well, before you go further, I have to get familiar. So in this case, very special. They are the same. You see, these 1, 2, 3 are the same. So we can you can use this formula. Can we? Can you try use this formula?
Yes. Can I just neglect this two because they are not affecting E?
Yeah. You need to have to work out the total resistors, right?
Yes.
Okay. I got annotated.
Plus.
That's right. You can probably write the result here. You can see it. Okay. The first is just R itself, right? The second, this is not right. 1 over R couldn't be right because its unit is the same. It's a reciprocal, can you see?
Right. Yeah. Right. Forgot. So it's
okay. We keep this right one. We keep this note so you know when you make a mistake. Yeah. Are you sure the third one is exactly R? So the second one is half. Can you see? This second one is half. Can you write the equivalent to that is half? Can you see? How about third one?
2R.
I think because they are identical. Can you see? Can we just use this formula for this case? Or can we just use this formula for this particular the 3 identical resistor, right? Because they are identical according to the formula you used, which is correct. So this equivalent is the third equivalent resistor reciprocal must equal to the sum of these 3 or 3 times this one. Can you see?
Yes.
The individual one is 2R. Can you see? So from here we can directly derive this. We just use the equivalent just one third of these 2R. Can you see?
But are the top and bottom resistors affecting P? Or is it?
At the moment, we have to work out the current first. Because the total current is unknown in the first place. Can you see? What is the total? Yes. We are trying to work out the total current at the moment.
I'm thinking about resistance.
Resistance, well, that's something you need to get familiar with. Can you see? I can highlight this one. So you have to use, first of all, work out reciprocal. Can you see? That, can you see the pattern? If these individual resistors in parallel are identical, and then the equivalent just 1/3 of it, can you see?
Yeah.
It's 1/3. So in other words, I give you the extension. So if you have, for example, if you have this resistor, can you see? So this is R. This is called R, and this is another one, and also all together they are all identical. but they have how many are these are all the just ask this question. So what would be this total equivalent RE if this total number is n equal to say 12? What is the equivalent resistance in this
R over 12.
Quickly, you just extended your knowledge, you generalize your knowledge here based on this fact.
Yep.
If that all components are resistance are the same, if you put them together, what is the answer very quickly? Because that will help you to save your time.
R over 12, because 12 in parallel.
Yes. What is how can we generate the formula?
Equals R over N.
Yes, that's right. So that's called generalization. Can you see?
Yeah.
So of course, if they are different, you wouldn't use that. Okay, so this is effective total. This is total resistance. Do you see?
Yeah.
This is total resistance of this circuit. Okay. In other words, we can use a single resistor whose value is the sum of these three to calculate the current in this DC circuit. You see what is this is a V, what is I? Yeah. Perhaps we will start from can we start from the Ohm's law, right? Because if you use Ohm's law, then can we write the formula first? Because after all, we are not dealing with number in physics. We are dealing with the idea and the formula.
Yeah.
So don't use a number before you found the result.
Okay.
Don't found the formula first. Found the formula for that. Yeah, that is current, total current. Okay.
Yeah.
Now, the total current and another thing, so we know that the current will be divided into small components. All right.
Mm-hmm.
Now, what would be the relation between each component and the total current here?
Is it like the opposite of resistance?
Well, what is this? What is current over here? Over across the P? Can we use IP? What current across the P?
The same as I?
No, of course. If you have water pipe, can you see? Water pipe was divided into three equal smaller pipe. Can you see? Can you see? So this current here must be the sum of these three components. Can you see?
Mm-hmm. What about voltage though? Are they all the same in parallel?
Voltage is another issue, but we have to work out the current because they are looking for the current, not voltage.
Mm-hmm.
If we know the current, we don't have to work out the voltage. Good question. Don't have to consider too many issues. Can we return to this question? Can you imagine that the water, just like water, can you see? The water pipe coming and they divide into three equal smaller pipe, can you see?
Yeah.
The resistance are all equal. So this current must be in each of smaller current must be identical, can you see?
Yeah.
To make it identical, if this is I, so this should be 1/3, can you see?
Yes.
And so does the central one, can you see? This also 1/3.
Yeah.
And also this is 1/3. So this you will get, I think gradually you will get familiar that when you see the current divided into the several parts, several components, and the total current, the incoming current must equal to the sum of the out current. It's called the Kirchhoff's law. Have you studied Kirchhoff's law?
No.
Junction law.
Yeah,
junction law.
I was thinking about junction.
Yeah, junction law. The junction law says the Kirchhoff is Kirchhoff, right? It's Kirchhoff, Kirchhoff, K-W-H. Kirchhoff's law. Okay, the junction is called the junction law. Okay.
Yeah.
You know the junction now. So this basically is I1 plus minus 3I IP, okay, that's equal to 0. Because we know this current is the same because the resistors are the same.
Yeah.
Got it? So in this way, we work out this current. So this is IP. So what is IP? IP will be 1/3 of your calculated current over here.
But there's no such answer.
But doesn't matter. We'll make sure we got the right message. Okay, we got
Yeah.
And you see, don't get excited about the answer. Okay, in older days, in the absence of computer, we have no multiple choice. Every student must work out the correct answer. So that is very more important. All right. So sometimes some people, whenever they say, that, okay, can you find any answer relevant to this one? Yes. So don't pay attention to the answer. Okay. And alternatively, for example, if we solve the problem, right, and none of these multiple choice provide the right answer, what shall we do? We double check if the message is correct. If we can convince the message is correct, then we can suspect that there's a misprint. Okay. It's more important to get the right message. Do you understand?
Yeah.
Okay. So we save this all. And clear that. Okay, I'll just do another. Go back to share screen. Okay, we probably this is math issue. Oh, you can try. This is a trigonometry issue.
Simpler form.
For cosine, sine inverse x.
So does it mean they're equal?
They are equal. So they have to ultimately become one of the following mathematical form expression. Have you thought of that possibility? So what is inverse? What does it mean inverse? How do we solve this type of question? Let me try.
The root sign looks like the derivative of
you have to write. You see, that's why in older day we don't think too much. We just draw the picture and write the alternative impression. You see, so nowadays people just just think. You have to. They are looking for this form. Can we just rewrite this form as y? I show you. Can we just let y equal this form? Can we? The cosine and the sine inverse x. Okay. Okay, can we simplify this?
Inverse y.
Yeah.
Inverse cos y.
So this is yeah. How do we enforce that?
Really? It looks weird.
It's weird. Yes, yes, inverse and inverse, yes. So because they're all inverse. So what is the relation between the two?
Do you find x? I don't know. No.
So this inverse cosine, right? Inverse cosine is equal to this sine inverse. Then we have to define, can we just build can we probably draw the diagram? Can we build the triangle to see what is the relation between the two? Say if I choose this is x, probably this is not the right way to go. Inverse and inverse doesn't help, equal to y cosine. Cosine. Yes, how can we start from here to move forward? Can we say y equal to x? Is that possible? Y equal to x? Can we make this conclusion?
Why?
I don't think so.
Yeah, I don't think so.
Because if they are, oh, hang on, this is cosine. No, they are not equal. They are different by 90 degrees.
So good.
Let's just see if they have the, because inverse can become this operator, can you see? So if you have this, well, one step here, there's a bit tricky here. So basically this cosine negative inverse. Inverse. So can we just go forward? Can we call this theta? Can we call this alpha? Can we call this theta? Do you agree? They are angles. Do you agree? This represented angle. Do you agree? So in other words, from these two, from this assumption, what you can, we can get there. Y is equal to cosine alpha. And can you follow me? X is equal to sine beta.
Yeah.
Okay. So alpha and beta, can we just call this our alpha? This is our beta. Presumably, we're just trying to figure out that question. Okay.
Yeah.
For X is by definition is opposite. Can you see this beta? Sorry, can we go to this one? Cosine. Cosine is opposite over.
Oh, that's not.
Okay, can we go to Y?
Yeah.
Can we call this I prefer use
So Y is the same side as X.
Really? Have you? Yeah, we nearly finished. Yes, we should be able to solve that one. Could be that the sum of the two equals to 90 degrees. So let's see. Or we just make that just start from ordinary triangle. So if this is cosine alpha, so that equal to 1. Can you see? So if the cosine alpha equal to y, that is possible. That is y1. Can you see? That's 1y. This alpha. Beta is x. Beta is because beta is sine. Oh, if you want to, this is by definition sine is opposite.
Yeah, the same
over hypotenuse, right? Opposite hypotenuse. But we cannot satisfy this condition, right?
But it is true though, because x equals y.
X equal to y?
Yeah.
Yes. That's possible, right? X equal to y. X equal to y.
Yeah.
Oh, no, this is wrong. No, this is wrong. This we can only judge this by alpha equal to beta. Oh, use this condition.
Yeah, in this
these two angles are the same. Oh yes, we just use this one. This alpha is also equal to beta. Can you see?
Yeah.
Can you see?
So they are on the same side.
On the same. So these two angles are the same.
Yeah, this is x.
Yes. Okay. Oh, Pythagoras rule will help you.
Yeah.
What is 1 square will equal to y square plus x square? We solve. Can you see?
Oh.
So what is y? What is
how do you know hypotenuse is 1?
Sorry?
How do you know hypotenuse is 1?
Well, because you see this y, this by definition, cosine alpha, it must be equal to 1. Can you see? This is, can you see this cosine alpha equal to 1? Can you see? Oh, hang on. Oh, sorry. Cosine alpha equal to cosine alpha, nearly finish. Cosine alpha equal to y over 1. Can we? It's not equal to 1, but this we can put the 1 here, can we?
Yeah.
So that's why this side must be 1. Can you see? So in other words, if we know y equal to cosine alpha, can we write that?
Oh.
Can you see that?
I think I'll never be able to recognize.
So this is adjacent, okay? This is hypotenuse. Can you see that? Anyway, we solve it. So y will be equal to square root. Can you see? And that is exactly what I'm looking for. Can you see? Which one? Which one? First one, can you see?
Yeah.
Can you follow me?
Yes. I think I'll never be able to like recognize this one.
Oh, we did just do some exercise, okay, like yoga. You can, it's a more practice, you know, you do it. Okay, I save that. Okay, we'll stop here today.
Okay.
Okay, I will send this to you. You can have a look.
I'm still thinking about it. Oh my god.
Okay, keep doing exercise problem solving.
Thank you.
Here comes.